Okay, so now I want to show you how to do the calculations of a Markov model where it follows it through the different stages of a life cycle of a tooth, and then it calculates the probability that it's sealed at the end, which we're calling the effectiveness. And the Markov model, it starts out as those state transition diagrams, like we saw in triage, or like you could see in the American Journal of Public Health article. But the underlying mechanics of a Markov model simplify to just a standard decision tree with these decisions, squares, chance nodes, circles, and terminal triangles. So a Markov model is a loop, but I'm going to show you here how the loop is really representing just this infinite tree, or this recursive tree that's going through these multiple cycles. So this is stage 0. So this is the tree representing stage 0 of the Markov cohort. So let's just choose, and I'm only going to show the top part of the tree for sealant A. So this entire slide will just be sealant A for simplification. Now after you choose sealant A at that blue square, it goes into this chance node, the circle, where there's some probability that it's sealed, some probability that it's extracted. And we said that for stage 0 of the Markov model, that the probability that it's sealed is 1.0, which makes the probability that it's extracted 0. So in stage 0 of the Markov cohort, it starts out where 100% of the teeth are sealed and 0% of them are extracted. So you can see me draw in the different probabilities for stage 0 of the Markov cohort there, where it starts out with a probability of 1 for sealed, 100% sealed, probability of 0 for extracted, 0% extracted. Remember, the probabilities coming off of a green circle, the probabilities coming off of a chance node have to sum to 1. So it's either sealed or extracted, and those probabilities sum to 1. Now remember, we measure effectiveness in this model as the probability that it's sealed. So at the end of stage 0, what's the probability that it's sealed? Well, that's just 1. 100% of them are sealed. So that's where it gets 1.0 for the probability of sealed for stage 0 of the Markov cohort. So when you look at that Markov cohort table in triage, it's going to say stage 0, 100% of them are sealed. That's where that probability is coming from. It just follows it through the tree. Now here I'm going to draw stage 1 of the Markov cohort. So remember, that top one, stage 0, that's just sort of the initial starting point where they're all sealed. And then where it starts actually cycling is in stage 1, sort of the first time that it cycles through this state transition. So now what happens is, given that it's sealed, there's going to be some chance that it stays sealed and some chance that it becomes extracted. So now you could see is that the tree just starts repeating itself, that the branches of the tree repeat themselves, and that's why it's a loop, that's why it's this repeating recursive structure that we call Markov. But the underlying mechanics is it's just a simple decision tree expanding through those different cycles. So the second tree here is where it has stage 0, and then that new part of it is going to be stage 1. So again, I just want to show you sealant A, the top half of the tree. I just want to show you how to do it for one sealant, and then let you do it for the other one. So you choose sealant A, you go to the first green circle, it either stays sealed or it's extracted. If it's extracted, you're done, tooth's extracted. But if it stays sealed and goes to that second green circle, then there's some probability that it stays sealed and some other chance that it's extracted. So the first part of this tree, again, that's just like it is above, right? So this is sort of stage 0, and now you can see me drawing stage 1 here. So stage 1 is where it starts going through that loop, where every year 75% of the teeth stay sealed, 0.75, and the other 25% of the teeth are extracted, 0.25. 0.75 plus 0.25 is 1. Probabilities have to sum to 1 after a chance node. But how do we know what the probability of sealed is after it goes through the cycle of the Markov cohort? So for the stage 1 model, after it goes through the cycle, you got those two probabilities of sealed. You follow the chance that it's sealed through the tree and you multiply them. So you could see choose sealant A, and then you follow those branches for sealed. You pick up the probability of 1, pick up the probability of 0.75, right? Choose sealant A, stays sealed, gets a probability of 1. In cycle 0, gets a probability of 0.75 in cycle 1. Multiply those two probabilities together. 1 times 0.75 equals 0.75. That's stage 1. So stage 0, probability that it's sealed is 1. Stage 1, probability that it's sealed is 0.75. And you see 1 and 0.75, you'll see those in the Markov cohort for stages 0 and stages 1. Now what's going to happen here for the next stage? Well, it's just going to keep expanding out. Remember, the Markov model is a loop. It's just the cycle. The cycle is really an infinite tree that just keeps expanding. It keeps cycling through these annual probabilities of extraction and annual probability of it staying sealed. So the top tree, stage 0 tree, second tree, stage 1 tree, and now this bottom tree here, this is stage 2 tree. So remember, we just ran the model in triage for 2 stages. So here we have stage 0 at the top, stage 1 in the middle, stage 2 at the bottom. But if you ran it for additional stages, right, you set stage 120 or you set it, 5, 7, 11, however many stages you want to set it, it's just going to keep repeating, right? You're going to keep adding these green circles and splitting off that sealed branch into sealed and extracted each year or each stage that you run through the model. Right, same thing again. So you choose sealant A, 100% of them are sealed, 0% are extracted. If it's sealed, there's some chance it stays sealed, some chance that it's extracted. Do another cycle, right? You have some chance that it stays sealed and some chance that it's extracted. So you can see how these branches of the tree repeat themselves and expand infinitely outward, or expand outward until all of the teeth have been extracted. We just run it for these cycles here, cycles 0, 1, and 2. And remember, the probabilities are just the same. So stage 0, right, 100% sealed, 0% extracted. If it's sealed, next stage, 75% stay sealed, 0.75. 25% are extracted, 0.25. If it stays sealed, the next year, the next cycle, there's another 75% chance that it's sealed and 25% chance that it's extracted. And again, you would just keep following this tree out, expanding it through more and more cycles. So what's the probability that it's sealed after we complete stages 0, 1, and 2? Well, now if you follow sealed all the way through this tree, you see you follow these sealed branches, you pick up probabilities of 1, 0.75, and 0.75. 1 times 0.75 times 0.75, probabilities of multiple events happening. You multiply them together, you get 0.5625. That's the cumulative effectiveness. That's the probability that it's sealed at the end of the model. That's the final cumulative effectiveness of sealant A in the ISER calculation.